When introducing Scrum, I talked about velocity as a way of capturing how much work you did in the previous iteration and using it to set the capacity for the next iteration. And so velocity is a capacity planning metric. There is a problem that we see on many teams and many organizations is that velocity ends up getting used as a productivity metric, as a way to see how well everyone is doing. And that has multiple problems. First of all, velocity is a relative metric. You cannot compare velocity across teams because different teams have different environments. They work differently, they estimate differently, their work is different. So anytime you see people trying to aggregate velocity across teams or compare velocity across teams, that's a terrible idea. That's not what velocity is for. And what happens is people will try and game it. The other problem that you see with velocity is that one set of people creates the estimates and then another set of people actually do the work. And so there's no feedback loop. And the people doing the work have different things in their head from the people who were making the estimates. So that can be problematic as well. The estimates should always be created by the people who are actually doing the work. And then finally, the moment you start measuring people based on velocity, people start gaming it. Goodhart's law states that when a measure becomes a target, it ceases to be a good measure. People will pad their estimates and they will stop doing work for other teams because that will reduce their velocity. And then people won't collaborate effectively. So for goodness sake, don't use velocity as a productivity metric. Don't compare it across teams. Don't make it a target, and make sure the people who are doing the estimating are the people who are doing the work. So if velocity is not a good productivity metric, is there a good productivity metric? Well, it's hard in software because there's no easy way to measure the amount of stuff you're creating, the inventory, if you like. Obviously, you can count the number of cars that come off a production line, but you can't really count the number of features that come out of a team because those features can be of very different sizes and complexities and impact. So you can measure, obviously, ultimately, the revenue that is generated by a product built by a team, but that is a trailing metric, and it's very hard, unless you're doing A/B testing, to connect that to what the team is doing. But even if you do measure the impact of the features you build on your organization, what you'll find is it's highly variable. Some features generate very large impacts and some features generate very small impacts. And that's because fundamentally, when we're building software products, we're operating in two different domains at the same time. What do I mean by that? First of all, you are operating in the domain of designing products and product development. So we're building new products and services and features that solve customer problems using our experimental approach, incorporating modern UX practices and design thinking. This is work that's never been done before. The estimates will be highly uncertain, and the outcomes, the impacts that those ideas produce will be very highly variable. And that's a good thing. We want things that are low impact to be delivered much more slowly than things with high impact. And unless there's high variability in the outcome, that means we're not taking enough risks. We're not doing things that are innovative. So when you're innovating, that's risky. Most things don't work out. Outcomes are highly variable. That's a good thing. That means we're innovating. However, once we have ideas, the process of getting them delivered, in other words, the code written and tested and integrated and deployed, that should be very different. What we want is fast flow from development to production and reliable releases. We want to standardize our work. We want to reduce variability. We want small batch sizes. We want that work to be performed continuously. And the cycle times or lead times for going from writing code to having it in production should be short and well known and predictable, and those outcomes should have very low variability. Software delivery should be a rapid and low risk process. That's what enables fast feedback in the product development process to allow us to validate our ideas about how to create impact and those customer and organizational outcomes. So we can't use velocity to measure the productivity of our product delivery process, but I've been involved in a 6-year program investigating software companies of all different sizes worldwide. It's the largest, longest running, scientifically rigorous study of software delivery practices and what's called DevOps, DevOps being the domain of product delivery in particular. And what we found by investigating thousands of companies over many years is that it is possible to measure the performance of your software delivery process. And there are 4 metrics that we can use to do that. One is deployment frequency, how frequently you release software. The next one is lead time for changes. How long does it take you to get changes from being checked into version control to released into production? And these first 2 metrics are metrics for speed or throughput or tempo. And then we've got 2 metrics that focus on stability. One is time to restore service. When there's some kind of problem in your production environment, how long does it take you to remediate and fix that problem? And then change fail rate. When you push a change into production, what proportion of the time do you need to roll back or roll forward or remediate or fix that problem in some way? Which is, if you like, a measure of the quality of the release process. And here's what we find. And if you take only one thing away from this, it should be this one fact. High performers are not trading off speed against stability. So when you hear move fast and break things, that is incorrect. High performers are moving fast and delivering higher quality and higher stability as well. When we've done cluster analysis for the responses for the surveys that we've been doing for 6 years, we've consistently found there's an elite performing group which does really well on these metrics, and then a low performing group that does really badly on these 4 metrics, and then 1 or 2 groups in between that are doing mediocre on all 4 of these metrics. So you can see that our elite performers are able to deploy to production on demand multiple times per day. They can get their changes out in less than a day, they can restore service in less than an hour, and they have this low change fail rate in this 0 to 15% bucket. Down at the other end, we have teams that are releasing every few months, and because they do these big bang releases, they take however long that is to actually get changes out, whether those are high or low impact, critical features or low value features, they all move at the same glacial pace. And then they're able to restore service in only the order of weeks. So if something goes wrong, it can take them weeks to fully remediate, and their change fail rate is in this 46 to 60% bucket. Anyone can be an elite performer. We find large, highly regulated companies in the elite performing group. We also find low performing teams in startups, in small companies. What you find is that large companies are much more heterogeneous than small companies. You find a wider variability in performance across teams in big organizations. Some are elite performing teams, some are low performing teams. So if you are a low performer, how do you get better? Well, over the last 6 years, we found many different factors that allow you to get better. This is a diagram we lovingly call the BFD, or Big and Friendly diagram. And if you go to cloud.google.com/DevOps and go down to look at the research program, you can find a version of this diagram that's interactive and explore it for yourself. And I don't have time to go through the whole findings of the 6-year program. I just want to summarize a few key results. Firstly, we find that the lean product development practices that I've been discussing this semester drive software delivery performance. They make you faster and more reliable. And that in turn drives organizational performance, which means improved commercial measures such as profitability, productivity and market share, and non-commercial measures such as quality and quantity of products and the ability to meet organisational and mission goals. So what is lean product development? It's things that we've been talking about. Working in small batches, splitting up work into tasks that can be delivered or stories that can be delivered in a few days. Making the flow of work visible, using story walls, Kanban boards to be able to track work as it goes through those various different statuses, as we discussed in the previous module. Thirdly, gathering and implementing customer feedback. And fourth, team experimentation. Teams should be able to experiment with new ideas for features, as we've discussed in previous units, and they should also be able to experiment with their process, which we're going to talk about in future units. So lean product development drives improved software delivery performance, improves speed and stability. It also reduces burnout on your teams. This is a feeling of hopelessness and cynicism that you can feel if you're really sick of working in a particular environment. It's a big problem on teams, particularly where people are very stressed out and they have high levels of responsibility but very little autonomy and authority. So using these lean product development practices, we've shown, reduces burnout on teams. It also improves culture, and we'll talk about that in the next unit. There's also an inverse relationship. The ability to deliver rapidly with speed and stability also impacts our ability to do lean product development, because it's only if we're able to deliver experiments rapidly into production and get feedback that we can actually adopt this experimental way of doing product development that we've discussed in previous units. So that experimental approach to product development combined with lean ideas like working in small batches and making work visible, that drives improved performance, and that improved performance enables us to better achieve that experimental approach to product development. Finally, lean management also drives improved performance, reduced burnout, and improved organizational culture. And here we're talking about practices like limiting work in process, trying to finish a few things rather than work on many things at once, as we discussed in the module on economic frameworks. Secondly, visual management, having displays where it's easy to see the quality of the work that you're doing and the status of the work that you're doing. Thirdly, feedback from production. And fourth, lightweight change approvals, which means reviewing changes inside your team rather than relying on managers or other teams to approve changes before they can be released. So these things are all management and product development practices that can drive improved software delivery performance, and in the case of these product development practices, drive improved organizational performance. Scrum can help with implementing some of these capabilities described here, such as working in small batches, making the flow of work visible, team experimentation, limiting work in process, and visual management. However, in order for that to happen, Scrum has to be set up correctly. You need to make sure that you have cross-functional teams that are empowered and have the authority to change the way they work and come up with new features. You have to make sure you're working in short iterations of 1 or 2 weeks and that you're actually delivering software during those iterations. You have to make sure that during your ritual meetings, your daily stand-up and your review meetings, that you're actually using a visual display and that is kept up to date. Unfortunately, many organizations don't implement Scrum in this way. They implement the rituals, but they don't actually set teams up in a way that they're able to succeed and implement these capabilities. And you've really got to watch out for that, because in that case, Scrum isn't going to help you achieve anything. It's crucially important as you're working on a team that you keep an eye on these capabilities and make sure that you're actually achieving them as part of your Scrum team's work. And this is the job of the Scrum Master, to keep an eye on that and to help teams actually work to do this effectively. One thing that Scrum does not talk about that's critically important in driving improved delivery performance is technical practices. And this is where extreme programming comes in, because extreme programming, as well as talking about a lot of the same planning practices that Scrum discusses, also discusses a number of technical practices that are crucial if you want to do a good job of delivering software rapidly, repeatably, reliably, and with high quality. So let's look at some of these technical practices. There's actually 14 of them that we in our research program have validated over the years. And it's everything from the way you manage software in version control, continuous integration, the practice of pushing changes into version control and testing them at least once a day, typically multiple times a day, and then fixing any problems that you find. Automating the process of testing and deploying your software, building security in, effective test data management and database change management. There's a whole bunch of things which I don't have time to go into. If you go to cloud.google.com/DevOps, you'll be able to visit our research program and explore all of these in a ton of detail. These practices together help you achieve what's called continuous delivery. This is the ability to release changes rapidly and reliably. And that drives improved software delivery performance. It also reduces team burnout. It reduces the deployment pain, which is the pain you experience on your team psychologically when you're doing deployments. And finally, it reduces the amount of rework you do, because all these things are about building quality into your software rather than trying to test it in after it's dev complete. And what that means is by making sure you get it right the first time, you don't need to redo it later on. So building quality in results in high quality software as well. So that's an extremely brief overview of some of the technical practices, and many of these are derived from extreme programming. Technical practices are as important as the management practices, and it's critically important to implement those practices as well as Scrum. So just to recap what we've discussed in this module very briefly at a very high level, you cannot measure team performance using velocity. It's just a capacity planning metric. You can measure the performance of your software delivery capability by looking at these 4 metrics. And if you go to cloud.google.com/DevOps, there's a quick check which lets you answer a few questions and find out how you're doing. If you want to get better at these things, you have to implement a combination of things, not just Scrum, but also a culture of experimentation and a set of technical practices as well. And those things together will help drive improved performance. We'll talk more about culture and high-performing teams in the next 2 units. That's what the remainder of the course is going to focus on. But before we do that, I just want to talk about one very important practice which both Scrum and XP discuss, which is the importance of retrospectives.